All right. So for like number one, all right, when we're reading through question number one on the pink page, all right, it says a volume of 26.5 milliliters. So what I would do there, you can cross out the word unknown right here. We're going to circle it. So we would write down V1 26.5 milliliters of nitrogen gas is collected in a tube at a temperature of 17 degrees Celsius. So temperature, but we can't leave it at 17. We'd have to add 273 to it, right? So when we add 273, that should be 290 Kelvin, okay? And a pressure of 737 millimeter mercury. So pressure 1, 737 millimeter mercury, right? So we just grabbed that from the problem. Then it says the next day the volume of nitrogen was 27.1 milliliters. So volume 2 is going to be 27.1, okay? And then with the barometer still reading 737 millimeter mercury, so now we have a new pressure, right? Millimeter mercury was pressure, so pressure 2, 737 millimeter mercury. What is the temperature on the second day, right? So looking at that, that should look very familiar. That's exactly what we've just been practicing, right? So you can plug it into the combined gas law. You can do PV over T equals P2V2 over T2, right? So you can do that. But one thing I want to point out, because really with the mixed gas law problem practice right here, it was to see if you could recognize which law to use, right? So what do you notice is the same? It's the pressure, right? So you could technically ignore the pressure information. I'm just lightly crossing that out, by the way. You don't have to totally cross that out, which means that I'm going to ignore the pressures right here. So now it just turned into a V over T equals V over T. That's Charles' law. And now it's just straight plugging it in, all right? But what I wanted to connect this to with the stuff that you were just now practicing, right, is that you can use combined gas law. It'll cancel itself out, all right? Having the 737 here, it's perfectly fine leaving it alone. So if you don't know how to reduce it down to one of the laws, just use your combined gas law and what you guys have been practicing. Now, number 3 over here has one extra part that makes it a little bit tricky. But remember, I made you guys write down at the beginning of the notes today what STP was, right? So on the notes page, remember, we wrote down STP values at the top. So I'm just going to kind of show over here. Again, ignore the U. So it says if 10 liters of oxygen, so 10 liters of oxygen is volume at STP, that just gave you 2 values. Just those 3 letters gave you 2 values. So temperature, according to my STP notes that we just wrote, that is 273 Kelvin. Okay, so me just telling you it's at STP is actually giving you information. All right, pressure is going to be, all right, so I have all of these to pick from. So looking through the problem, it says what will be the new volume, blah, 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 blah. And then it has this millimeter of mercury. So that tells you we need to use this value. 760 millimeter mercury. Okay, it's going to be heated to 512 degrees Celsius. That means a temperature 2 would be that plus 273, right? So that'll be 785 Kelvin. And then new volume, so that means V2 is who we're solving for. And the new pressure was 1,520 millimeter mercury. Okay, so now I'm hoping that looking at that, that's not as scary because you now know combined gas law, you're just plugging into that every single time. And it's always your fallback, all right? So when in doubt, start plugging it into the combined gas law. There's the only one that you're not going to see work with that is Avogadro's law dealing with moles. Because we didn't put the N in there, I can show you that on another day, but N would go next to the T down here. Okay, but don't worry about that right now. If you find one with moles, use Avogadro's law, right? All right, so good job. Nice work.